Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now. Hi.
Oi, so they give access to their job portal, Geeks for Geeks, for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes ways. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hello and welcome back to this amazing channel Geeks for Geeks. This is Abhinav and today we are back with our next problem of the day, which is nothing but find number of closed islands. So it's a problem something similar to the problem which is find number of islands, okay, which is based on the like find or count number of connected components in graph, okay. So for good evening Madhur. So for those who have learned graph, they must have solved a problem which is solved in DFS actually, which is solve like find the number of components in a graph, okay. So that's actually the basic problem that we have here, okay. So but if we talk about in this particular case here, we have to find number of islands, a number of closed islands, so extra parameter closed is involved, okay. So let's see how we can solve this particular problem. Please let me know if I'm clearly audible and visible to you all, and the screen is also visible now, I hope. Okay, great. So you can see guys, this is the problem. Like simply you have to find number of closed islands. So islands, you all know, like this is also island, this can be considered as island, okay. This is also island, okay. this is also an island. But as they are saying number of closed island, so as they are saying number of closed island, that simply means that they are saying that only zeros on all the boundaries except diagonal. Okay, thing is what they are saying is that in that diagonal which you have to find, it's not a simple diagonal. It's not, sorry, it's not a simple island. Okay, in this island what they do is the boundary element cannot be one. Got it? They should not have a boundary element which is one. Got it? So boundary element should not be one. If the boundary element is one, that means it's not a closed island. We will not count it. Okay. So that's the basic thing we do. Got it? Yeah, hi, Madhur. Great. So see, the very first thing that we will do here is we have to write a DFS approach, obviously. So for a DFS approach, what we do? For a DFS approach, the very first thing that we need is a visited vector. Okay. So we'll take a 2D vector the same size. So you can see here we also have. Let me open a full screen. I will make it small and M. Okay. So you can see, guys, one thing here that first of all I will take here a 2D vector. Okay, and that vector 2 of size the same size that we're having, and initially I will make the values of that vector as false, just like we have in our visited vector of like we use in other cases also. Okay, that's a basic thing like this. Okay, and initially all the values are false. Now, guys, what I will do, I will for sure store a count of what? Count of closed island that we have to count. So initially it's 0. Okay. Now, guys, for every index, like for all the indices from I, comma j, like for every I, comma j, for all the islands, as the islands are in a 2D matrix, na. So I will iterate through each and every cell of the 2D matrix. Okay. Each and every cell of the 2D matrix I will go. Okay, great. Now, guys, the very first thing that we will do. Okay, so the very first thing that we have to check is that if the matrix value of that particular cell is 1, that's the first thing that you have to check. The first thing is that the matrix value of the thing should be 1, and it should not be visited. So because the cell is already visited, that means that particular element is all, or that particular component, or I can say island, is already calculated or already counted. Okay, so if the matrix is 1, visited is false, then only I will perform my operation. Okay, one more thing I will check. I have to also check for the corner case, because the given INA should not be corner. As you can see, the definition here, the definition was that island should not have ones in its boundaries. So boundaries में one नहीं होना चाहिए. Okay, so this is the thing that we will check. That, sorry, yeah. So we will check this thing that in boundaries we should not have this ing. Okay, so we'll simply check whether this ing not lie in the boundary. So if I is not equal to 0, my boundary is 0, j is not equal to 0, and I is not equal to n minus 1, means the last row, and j is not equal to m minus 1, means the last column. Okay, so if these both the things, if these all 4 things are matched, okay, now we'll apply, now we'll call for the BFS algorithm or DFS algorithm. Okay? So we'll write a DFS here. In that DFS, what we will do? Okay, so till now, is it clear to you, Madhbar and everyone? Great. Okay, great. Now I will first check a void, and I will check whether it is a corner, a closed island or not. So I will write here a Boolean check, and I will initially assume that it's not a closed, or I will simply write here. I will simply write here that whether it is closed or not. Okay, Boolean closed. Okay. Now I will call for the BFS algorithm for the given matrix, for the given visited matrix, for this I, j, and m, and also I will pass this closed, which will ultimately store my answer, that whether the given matrix is closed or not. Okay. Now let's write the Boolean. Let's write this BFS function here. Okay. See. Now let's see what is the BFS function. What the BFS function is actually saying. Okay. So guys, in the BFS function, eventually what we are doing is, okay. Yeah. So what we are doing, first of all, we will take these all the inputs, the input of the matrix and everything. So it will be a simple void function, void DFS. Okay. It will be having first this matrix, then it will be having the visited matrix for sure. Okay, it will be of Boolean. Bool. Okay, now it will be having I, j, n. Okay, I, j, n. It will be having a m, and apart from that, it will be having this bool close. Okay, which will store the answer. Now, guys, see. Now, first of all, what I will do, I will check if these all any one of the conditions not to see. If x is less than 0 or y is less than 0 or x is greater than equal to n or y is greater than equal to m. If any one of these conditions is true, why? Because these all means that this x and y is out of the matrix. One more thing, or if my visited ij is true, means it is already visited. It is already visited. Got it? Or one more thing, or if the current value of the matrix is 0, because 0 is not a land. 1 means land, 0 means water, and in water there cannot be island. If any one of the thing is there, it's the base case written. This is the base case. Okay. Now, guys, now next comes is the recursive case. Now I will check for the corner cell. Guys, just like I've checked here, similarly I will check here also. Okay. Okay, so I have taken x and okay, let's take here x and I've taken I and j, na, not x and y. I'm seeing the coordinates x and y, but we are taking here as I and j. Okay. I hope now it's fine. Fine. Now, guys, see, if the current cell is the corner cell, means if x is equal to 0 or y is equal to 0 or x is equal to n minus 1 or y is equal to n minus 1. If any one of these four cases are there, then what to do? Then you will see if that matrix value, by the way, this matrix will always be 1. Okay. If this matrix value is also 1, it will be 1, by the way. That means it is not actually a close. Got it? So what does it mean? Actually, I have done a not thing. I have to write a not closed. Why not closed? See, guys, we have to count for the exactly for the boundary cases. Exactly. So you can see here, Madhur, that for every ij, again I've taken x and y. For every ij, what I will do is that I will be checking whether it is a corner cell. So if it is a corner cell, as I told you, in closed island, there cannot be a corner cell. So if the given cell is a corner cell, I will make my not closed equal to true. It's not closed. Not closed nahi. Got it? It's a not closed. Closed nahi hai. It's a not closed. Okay. And then at the last, I will make my visited of I and j as true, because it's now we have visited it. And now for all the adjacent, like let's say we are at I. Okay. See, let's say we are at I. So I will check for I plus 1 comma j. I will check for I minus 1 comma j. I will check for multiple such indices. Okay. That is the next thing that we will do. Okay. So if we are at a particular place, we have to check for all the 4 top, bottom, left, and right, all the 4 cells. Okay. So you can see here that if we are at I comma j, I have to check for I minus 1 comma j, I plus 1 comma j, I comma j plus 1, and I comma j minus 1. So I have to check for all the 4 cells. Got it? I have to check for all the 4 cells that we're having here. Fine. Simply what will happen? That here, the DFS of I plus 1 comma j, comma all these like first table matrix and the visited, and then apart from that the values of n, m, and not closed, that will also be same. I will check for all that 4 things, not just this. So you can see here at first is then it's for I comma j plus 1. Okay, then it's for I comma j minus 1, it's 5 minus 1 comma j. Okay, and then it will be checked. Got it? Now guys, at the last what we will do, we will simply return my count. Now here if that is closed, like if not closed is false, means if that island is closed, that means I will increase my c. Okay, that is what we'll do. So if you will compile this particular code, so it was a program. Exactly. Okay, it should be not closed, no? Where is closed given? Uh, 52. Okay, here it should be also not closed. Okay, guys. So this is how like we are solving this problem. So if you will see here, okay, we have got the wrong thing. What's wrong thing happened here? Okay, here we have to take the reference of this not closed. We have to take the reference for every, okay, it should be a reference, so that for every recursion call that not closed should be stored. Okay, that's the wrong thing that happened actually. Yeah, now we have solved the problem. Okay, so this is how we are solving the problem. You can see here. So if you want, I can provide the solution link also. Okay, I hope you have got it. Great. This is the link for the code. Okay, guys. So I know, yeah, it was a really hard problem. As you can see, it was a hard problem. Okay, so it will need some time for you to understand clearly. Okay, this is how we are approaching it. I hope you've got this particular problem. Okay, this is the time complex of n to m, but we are having a recursion call also. Okay, for every test case actually. So that's all for this particular video. Live. Thanks for watching the video. Thanks. Happy coding. Take care. बाय बाय, लेट्स मीट अगेन टुमारो नेक्स्ट पीओडी. जीएफजी कर लो, हो जाएगा.